All right, let's tour the ultimate power plant, our sun. We're going from its fiery core to its violent surface.
So just how big are we talking? Well, it would take over 1,000,000 Earths.
Just to fill up the sun. That's right, it's almost unimaginably huge.
And get this, it's got nearly all the mass in our solar system. That's what holds us all in orbit. Okay, let's dive right in. Our journey starts deep inside the sun's fusion engine. Down here, we're talking 15 million degrees Celsius. Yeah, that's hot enough for nuclear fusion.
So every second, matter becomes pure energy, and that's the energy that powers our whole world.
But you know, that energy doesn't just pop right out. It's got a long journey through 3 different zones.
Believe it or not, a single photon can take 170,000 years just to get through one of those zones.
The final layer is basically a giant boiling pot. That's what brings that ancient energy to the surface.
And all this churning doesn't just move heat, it also creates the sun's powerful, twisted magnetic field.
It's a two-step process, really. A stretching motion and a twisting one, working together like a dynamo.
This whole engine drives the sun's famous 11-year cycle and even a 22-year magnetic pole flip.
All that stored up magnetic energy? Well, eventually it has to go somewhere, like an eruption.
But here's a mystery. Why is the sun's atmosphere millions of degrees hotter than its actual surface?
Well, we think we've cracked it. Tiny, twisting magnetic waves are carrying that heat upwards.
Now, when these magnetic fields get too twisted, they can snap, unleashing these huge explosions.
It's called magnetic reconnection. It creates massive flares and can hurl plasma right into space.
And those eruptions, they create what we call space weather, which can actually affect us here on Earth.
A big solar storm could mess with our tech, but it's also what gives us those amazing auroras. So our sun's a middle-aged star, but nothing lasts forever.
It's about 4.6 billion years old right now, so it's pretty much halfway through its stable life.
In another 5 billion years or so, it'll run out of fuel and swell up into a red giant.
When that happens, it's going to swallow Mercury, Venus, and probably us too. Then it'll collapse. So our star has a definite end. The big question is, what else will it teach us before then?